Welcome to the deep dive. Ready to explore photogrammetry?
It's good.
We've got a ton of cool stuff to look at today. Articles, blog posts, even some predictions about the future. We really want to give you a solid understanding of photogrammetry, from way back when to what it could mean for you going forward.
Yeah, it's come a long way. From just basic mapping to stuff like engineering, archaeology, even virtual reality.
Exactly. So to kick things off, we're going way back to 1955 with this article by George D. Hardy. He was a photogrammetric engineer, and even back then, he was already seeing some big changes happening.
Interesting.
Yeah, so back then, photogrammetry was mostly used for reconnaissance, just getting a basic look at a site. But Hardy thought it could be so much more. Like, he really believed it could be used to make the final designs for engineering projects.
Wow, ahead of his time.
Right. And he also pointed out that the U.S. was kind of falling behind Europe when it came to innovation in photogrammetry. He was really pushing for more engineers to work together and share knowledge.
Makes you wonder if they caught up.
Yeah, for sure. Something to think about as we go through all this stuff. Okay, so let's fast forward a bit now to 1973. Think supersonic flights, moon landings, computers designing computers. Did the world even have time for photogrammetry?
Apparently. We have this article by Frederick J. Doyle. He was with the U.S. Geological Survey, and he was writing about how photogrammetry could actually help solve some big problems in the world, like pollution and managing resources. It wasn't just about mapping anymore. It was about using that data to understand these huge issues.
Okay, so it was already becoming a lot more than just a simple tool. And this is where it starts to get really interesting, I think, especially for your work. Doyle also mentioned the launch of the first Earth Resources Technology Satellite, or ETS for short. This was really the beginning of what we now call remote sensing, with satellites gathering tons of information about the planet. This must have been a huge change for photogrammetrists. Now they have all this new imagery to work with.
Oh yeah, for sure. It was a challenge, but also a huge opportunity. They had to come up with new ways to process and analyze all the satellite data, but it also opened up all sorts of new possibilities for mapping and studying the Earth on a much bigger scale than before.
Wow, so photogrammetry went from this niche tool to something that could impact the whole planet.
Exactly.
Okay, so that's how we got from the early days to this idea of global impact. But let's jump to the present day. We found this blog post that shows just how accessible photogrammetry is now, thanks to things like drones and easy-to-use software. You don't have to be some kind of expert to create detailed 3D models anymore.
Right, and that's a game changer. The blog explains it really well, too, using these concepts like triangulation and parallax. And you mentioned drones. They're perfect for this. You can fly a drone over a site, take a bunch of overlapping pictures, and then the software stitches them together to create a 3D model.
It's like having a digital twin of the real thing. And there are so many different applications now. Like, they gave this example of civil engineering using drones and photogrammetry for quick topographic surveys and building 3D models for planning and checking on construction projects. I bet that's super useful in your work, right? Especially with the kind of large-scale projects you do.
Oh, absolutely. The detail and accuracy you get with photogrammetry is so important for those kinds of projects.
Yeah.
You can spot problems early on, make the designs better, track progress more efficiently. It's not just about being fast, though. It's about safety and getting things right.
So it's changing how these big projects are run, basically.
Yeah, for sure.
And that's just one example. I'm really interested to hear more about how it's being used in other areas, too.
Oh, yeah. There are so many. Oh, yeah, tons. Like, we have this Wikipedia entry here talking about close-range photogrammetry.
Yeah.
It's basically using the same ideas, but for smaller objects, and it's got some really cool uses.
Okay, smaller objects. So what kind of things are we talking about here?
Well, it can be used in rock mechanics to analyze, like, rock slopes, see how stable they are, and try to predict if there might be any hazards, to help prevent landslides and stuff like that.
That's super important, especially in areas with earthquakes or a lot of erosion, right?
Yeah, exactly. And get this, it can even be used for accident reconstruction.
Wow, really?
Yep. Collision engineers can use it to, recreate accident scenes in 3D, even if it happened years ago.
That's wild.
It helps them figure out what happened, like the forces involved and all that. It can be really important for investigations and making things safer.
So photogrammetry is like a time machine for data. That's incredible. But okay, let's switch gears a bit and talk about the future. We've got this article from JIM International all about how photogrammetry is still evolving and how new sensors are making even more things possible. They mention things like SAR, flash lasers, and mobile LiDAR. Can you break those down for us? What are those and how are they changing things?
Sure. So each of these sensors has its own special abilities. SAR stands for synthetic aperture radar, and that was particularly useful in your line of work, actually. It can see through clouds and vegetation, so you can get data even in bad weather or like really dense forests.
That's really useful.
Yeah. It's perfect for mapping areas that are hard to get to or where you can't always fly over.
So even when you can't use regular aerial photography, SAR can still get the job done. What about flash lasers? How are they different from regular LiDAR?
Well, flash lasers are super fast. They can capture data in an instant, which makes them great for situations where things are changing quickly. They send out this pulse of light that covers the whole area at once, unlike regular LiDAR, which scans point by point.
Oh, I see.
Yeah, so you can use them to capture things like landslides or coastline, just
Yeah.
changing really accurately.
It's like taking a super high-resolution photo of a moment in time. Okay, and last but not least, mobile LiDAR. I've heard that's becoming really popular for those big mapping projects. What's the advantage of using that?
Well, mobile LiDAR systems are usually mounted on vehicles, and they can scan huge areas super quickly and accurately. They're used a lot for mapping highways, railways, cities. You have to get really detailed 3D models of all that stuff.
Sounds efficient.
Yeah, it is. And that data is really important for all sorts of things, like managing infrastructure, keeping things maintained, planning cities, and even responding to disasters.
Okay, so with all these amazing sensors collecting tons of data, how do we even manage it all?
That's where things get even cooler. We're starting to see photogrammetry combined with all these other amazing technologies like cloud computing, artificial intelligence, even crowdsourcing. Cloud platforms can store and process all that data. AI can help with things like finding specific features or identifying objects. And crowdsourcing can actually involve people, citizen scientists, in collecting and analyzing data. It's like a global team effort.
Wow, so it's not just about the sensors themselves, it's about this whole network of technologies working together.
Exactly. It's pushing the boundaries of what we can do with all this data.
And speaking of pushing boundaries, there's this big debate going on right now about the future of aerial photogrammetry. We have this article from XiHT that asks the question, will drones replace airplanes for collecting data?
That's a good question. Drones have gotten super popular for photogrammetry, but can they really do everything a plane can do?
Yeah, I mean, planes can cover so much ground.
Right. Well, the article compares things like how long they can fly, how much area they can cover, the quality of the images they capture. Drones are definitely more agile and cheaper, and they're great for mapping smaller areas in high detail. But planes are still better for covering those really large areas quickly, and they can carry bigger, more advanced sensors.
So it's not really a case of one replacing the other?
Yeah, it's more like photogrammetrists now have more choices. They can pick the best tool for the job, whether that's a drone or a plane.
Makes sense. But even with all this progress, I'm sure there are still some challenges, right? Like, what are some of the things that are still holding photogrammetry back from reaching its full potential?
Yeah, definitely. There are a few things. There's this article here called Trends in LiDAR and Photogrammetry Technology, and it points out some of the key challenges. One of the biggest ones is that we need better, more reliable, and cheaper LiDAR systems for drones.
Yeah, I can see how that would be a hurdle. LiDAR is expensive, and putting it on a drone isn't easy.
Right. And another big challenge is that the software used to process the data can be pretty complicated. It's gotten easier to use, but there's still a lot to learn. The article suggests making the software more intuitive so that people who aren't experts can use it more easily.
So basically making the technology more accessible to everyone.
Yeah, exactly. That could lead to some really cool new innovations. But, while we're talking about all this technology, it's important to remember that it's the people who are driving all this progress. We have this presentation here from Intergraph. They're a big company that makes geospatial solutions, and they seem to be really focused on the human side of things.
Okay, what do they have to say?
Well, they're really on board with all the trends we've been talking about. They talk a lot about providing solutions for the entire process of Earth imaging. From collecting data to processing it, analyzing it, sharing it. They really emphasize productivity, ease of use, and making sure that their systems can work with other systems, open interoperability.
Yeah, those are all important things, especially with so much data being collected these days.
Right. They basically want to make photogrammetry a seamless part of GIS, using web services and things like that to manage all this data on a global scale.
That's a big vision. But with how fast technology is moving, it might not be that far off.
You never know.
It's definitely an exciting time to be working in this field. We've come a long way, and who knows what's next. So much to unpack. It's amazing to see how far photogrammetry has come from those early days and how it's kind of become a part of everything.
Yeah, it really has.
So before we wrap things up, let's just recap some of the key things we talked about. We started with George Hardy back in '55, remember? He had this idea that photogrammetry could be way more than just basic mapping. Like, it could actually be used for designing engineering projects.
Right. And then we moved on to Frederick Doyle in 73. He was talking about how photogrammetry could be used to solve some of the big problems in the world, like pollution and managing resources. Plus, that's when we saw the launch of the first Earth Resources Technology Satellite, or EVATS.
Huge moment. That was like the beginning of remote sensing, and suddenly photogrammetry wasn't just about what you could see from the ground anymore. It was about this whole new perspective of the Earth from space.
Exactly. And think about how accessible it is now.
Yeah.
We talked about drones and software that anyone can use. You don't have to be a scientist to create those detailed 3D models anymore.
Right. It's really opened up the field to so many more people, and you see that in all the different ways it's being used now. Like,
Yeah.
we talked about using drones for those quick surveys and building 3D models for construction projects.
Oh, yeah. You mentioned how helpful that would be for the kind of projects you work on.
Totally. And it's not just construction, though. We talked about archaeology, how they use it to document and preserve sites, and geology for analyzing terrain and predicting things like landslides, even accident reconstruction, like figuring out exactly what happened years after an accident.
It's amazing how many different applications there are and how the technology keeps evolving. We talked about all those new sensors, SAR, flash lasers, mobile LiDAR, each one kind of pushing the limits of what we can do with photogrammetry.
Yeah, like SAR, being able to see through clouds and stuff. Super useful when you're working in those remote areas or places where you can't always get a clear view from above.
Right. And flash lasers capturing those super fast events with incredible detail. And then mobile LiDAR for those huge mapping projects, mapping out entire cities or landscapes with amazing precision.
It really makes you think about how much data we're collecting now. It's almost overwhelming.
It is. But that's where all those other technologies come in, the cloud computing, the AI.
Yeah.
It's all about finding ways to manage all that information and make sense of it.
And to make it easier for people to use too, right? Like that article we discussed talking about making the software more intuitive so anyone can use it, not just experts.
Absolutely. That's key to really unlocking the potential of photogrammetry and letting everyone benefit from it.
Couldn't agree more. It's not just about the tech itself. It's about how we use it to solve problems, make things better, make a real difference in the world.
Couldn't have said it better myself.
So as we wrap up this deep dive, I want to leave you with this thought. Look around you right now and think about all the ways photogrammetry might be playing a role in your life. Maybe it helped build the building you're in, or manage the park you walk through, or create that video game you love playing.
Or maybe it even helped preserve that historical landmark you visited on vacation.
It really is everywhere. It's amazing to think about how this technology that used to be so specialized has become such a big part of our world. And who knows what the future holds. Thanks for joining us on this journey into the world of photogrammetry. We'll see you next time on The Deep Dive.